Today's video is chapter 7.3. You're going to learn how to go from the mole and convert that into molecular weights. All right, so it's the mole and molecular weights. We're going to go from the mole and we're going to learn how to go into weights like grams and vice versa back to the mole. Okay, let's get started. So moles and molecular weights. If I was to take just one carbon atom and weigh it, it would weigh 12.01 AMUs, atomic mass units. And that's if I just have one carbon atom sitting in my bucket. But let's say I was to take 6.02 times 10 to the 23rd carbon atoms. Interestingly enough, that would weigh 12.01 grams. And this is where the mole comes from. This is where this number comes from. 6.02 times 10 to the 23rd of anything weighs its atomic mass in grams. Okay, so it's a quantity. A mole is a quantity of any sample whose mass equals its atomic number. Or its atomic mass, sorry. So quantity of any sample whose mass equals its atomic mass. So 6.02 times 10 to the 23rd carbon atoms is 12.01 grams. One carbon atom weighs 12.01 atomic mass units. So 6.02 times 10 to the 23rd weighs that same number in grams. And that does that for carbon atoms, it does that for hydrogen atoms, it does that for H2O molecules, it does it for anything. And that's why this number, Avogadro's number, is so important. And also remember, I just want to point out that this number comes from number of protons plus the number of neutrons, okay? So we get that proton-neutron number in grams when we weigh 6.02 times 10 to the 23rd carbon atoms. All right. So now that we've realized that this mole number is really important because it takes us from atomic mass units into grams, we can almost weigh anything we want. So let's say I was to put 6.02 times 10 to the 23rd hydrogen atoms. Which is 1 mole of hydrogen. That would weigh 1.008, pretty sure, 1.008 grams. And we can just find this number on the periodic table. So a mole of hydrogen weighs its mass in the periodic table. Let's say I put 6.02 times 10 to the 23rd oxygen atoms. Should be 1 mole of oxygen. That would weigh 16 grams, which is also the number on the periodic table. So now, let's say I put 6.02 times 10 to the 23rd H2O molecules. So this would be 1 mole of H2O. How much would that weigh? That would weigh 18.016 grams. Now, you're probably asking yourself, where does that come from? Well, H2O is 2 times the mass of hydrogen, because there's 2 hydrogens, plus 1 times the mass of oxygen. So let's do this out. 2 times 1.008 plus 1 times 16 equals 18.016. Okay, so this is how you calculate molecular weights. You just take the number, the mass of the element times how many there are, plus the mass of the next element times how many there are, plus the mass of the next element times how many there are. Okay? All right. Let's keep moving on. So let's calculate these molecular weights. So 1 times, and on the periodic table, carbon's weight is 12.01, plus 2 times the weight, which is of oxygen, which is 16. So let me calculate that out. So we have 1 times 12.01 plus 2 times 16. So that equals 44.01 grams per mole. Okay, let's do the next one. So we have 6 carbons, 6 times, and then 10 hydrogens. So 6 times 12.01 equals 72.06 plus 10 times 1.008 equals 10.08, and then we add those two together, 72.06 equals 82.14 grams per mole. Grams over mole, okay? Molecular weights, remember, we have our bucket on our scale. So it's the number of grams per 1 mole, okay? Grams per mole. All of these are in grams per mole. And now let's do HCl. We have 1 times hydrogen's weight plus 1 times chlorine's weight, which equals 35.45 plus 1.008, 36.46 grams per mole. Okay. If you do not know how to calculate molecular weights, or this page is so confusing to you, please raise your hand, okay, and have me come over and explain each one. If you're feeling confident, you can move on. So now we're going to convert between grams and moles to grams, okay? This is really important. If I'm a chemist and I want to weigh out a certain mass, I need to know exactly how much. And it needs to be accurate. Like, I don't want to weigh out 20 more grams than I actually need. So going from moles to grams and grams to moles is really necessary. All right, let's get started. So if I'm going to go in from moles into grams, I'm going to multiply by the molecular weights. All right, so I'm given a certain number of moles. of something. I'm going to multiply that by the molecular weight of that thing to get how many grams. Okay? The mole up top is going to cancel the mole on the bottom, leaving me with grams. So that's what I'm going to get at the end. Okay, and so if we take a look, again, we have our bucket on our scale. We have our 1 mole. And we have our grams. I need to know how much one of these things weighs. How much one of those atoms weighs. Or how much is 1 mole of those atoms weighs. To know how many grams I have. Okay. All right, let's give this a try. So how many grams of CO2 are in 3 moles of CO2? So the little equation showed us that we have the given moles. So 3 moles of CO2 times in 1 mole of CO2, we have to plug in the molecular weights to get the grams. So what is the molecular weight of CO2? So it's carbon, one times 12.01 plus 2 times 16. So 2 times 16 plus 12.01 equals 44 grams per mole. I'm going to put this in a different color so you can see where it goes. So my 44 grams per that 1 mole goes there. So now I take my 3 times my 44.1, and this shows me that I have 132.03 grams of CO2 in those 3 moles, okay? And the mole here cancels the mole there, leaving me with grams. Let's do the next one. How many grams of NaCl are in 2 moles of NaCl? Well, first we need to find the molecular weight of NaCl, and it's 22.99 plus 35.45, and you can find those numbers off the periodic table. So that equals 22.99 plus 35.45 equals 58.44. I'm actually going to put it in purple. Same number, I'm just putting it in purple so you guys can see it. 58.44 grams per mole. So now I have a given 2 moles of NaCl. So I have my 2 moles of NaCl times, in that 1 mole, NaCl weighs 58.44 grams. Which equals 2 times 58.44 equals 116.88 grams of NaCl. And again, the moles cancel, leaving me with grams. Okay? So you just simply take the number of moles you have and multiply it by the molecular weight of that compound or element. Okay, let's move on to the next. So now you're going to turn grams into moles. So instead of starting with moles, you're going to start with grams. And you do this by dividing by you do this by dividing by the molecular weights. And if we look, we have grams up top, we have grams on bottom, leaving us with moles on top, so we're going to get moles in the end. And so here you have your bucket that you're weighing out with your stuff. And you're trying to go from grams into how many moles you might have on that bucket. Maybe you have 1, maybe you actually have 2 stacked on top, maybe you have 3 that you've weighed, okay? You don't know. So you have to go from how many grams you have divided by the molecular weight of that gram to then get how many moles you have. Let's practice. So first thing we need to do is calculate molecular weights. So how many moles of MgO are in 45.67 grams of MgO? Well, we have 1 times magnesium, which is 24.303 plus 1 times oxygen, which is 16. So now we just add those together. 24.303 plus 16 is 40.303 grams per mole. So now we're going to start with what we're given. We're given number of grams. So we have 45.67 grams of MgO. And we're going to divide by our molecular weight, which is 40.303 grams of MgO per 1 mole. And that is going to equal how many moles we have. So 45.67 divided by 40.303 tells me that I have 1.13 moles of MgO. And again, my grams on the bottom cancels my grams up top, leaving me with moles up top, so I'm going to end with moles. Okay, and last one. How many moles of C5H9O are in 113 grams of C5H9O? Okay, so let's do the molecular weight. So carbon is 12.01, hydrogen is 1.008, and oxygen is 16. Carbon times 5, 1.008 times 9, and 16 times 1. We add all that together, so 12.01 times 5 plus 1.008 times 9 plus 1 times 16 equals, let's see, 12.01 times 5 is 60 plus 1.008 times 9 is 9.072 plus 16. Let's add all that together. 85.07 grams per mole is the molecular weight. And so now we have 113 grams of C5H9O times the molecular weight. We're going to divide by the mass, 85.07 grams, gives me my 1 mole, and that equals 113 divided by 85.07 equals 1.3 moles of C5H9O. And again, we start with grams, we divide by grams, leaving us measuring moles, so we're going to end with moles. Okay, that was your quick 20-minute notes video. Now you're going to take these notes and apply them to your 8 homework problems. All right? Okay, good job, guys. Keep up the good work.